Okay, YouTube, in my last couple of videos, we've taken equations that are in parametric form and rewritten them in rectangular form. In this video, we're just going to really quickly say that we have, say, a rectangular form equation. Maybe we want to write this parametrically and say, well, how could we define x and y as functions of time if we have a rectangular form equation? What the thing here is this. Usually, you're going to describe x and y with respect to time using different equations that you might actually have to calculate based upon data points, okay? But in most instances, if we said we just want to introduce a parameter, what we do is we just say, well then fine, I'll just let x equal the same thing as time. What this does, then it makes defining y really easy because we're saying, well, if x is equal to time, essentially we're going to let x equal t. Then what we know is y equals 2x plus 1. Well, then that would mean that y equals 2 times t plus 1. And you could see that y would just be a function of time if x is equal to the time that is flowing and t is equal to time in the first place and not some other parameter. It could be anything. I just keep saying time. But maybe let's just say in this case, okay, we did some observations and we know that time is equal to the x displacement plus 2. You know, something, I don't know. But here's the deal. In this case, it's a little bit more complex. And what we're going to have to do is we're going to have to say, well, then x is equal to what? You know, here's the deal. We have x and y, and we need to define x as a function of time. We know time is equal to x plus 2. So if we solve for x here, what we get is essentially that x is equal to t minus 2. And so we could say t minus 2 is what x is equal to. And we know that y equals 2x plus 1. So here we have this. We have 2x plus 1, where our x value here we have defined as being our time parameter minus 2. So now we get y equals 2 times t minus 4 plus 1, which y equals 2 times t minus 3. I'm going to put a box around this, and I'm going to put a box around that. And I'm going to rewrite them over here so it's a little bit more cleanly written. But essentially, we would say that this would be the parametrically defined version of this rectangular form equation here, which, by the way, was just as good as this parametrically defined form over here. It's just that in either instance, we're saying that time was related to, say, x, or it could have been related to y differently, and we had to use that to go plug into one and then go plug that into the other. But that's how you write an equation in parametric form. You have to say x or y or any of your variables is equal to something with respect to time, and then go substitute it into the other one. Cheers.